the section formula, that is when a line segment is divided by any point in the ratio m:n. The distance of AC is the sum of distance of AB plus BC. If we prove this result using the distance formula, we can say that they are collinear. If we square on both sides, we get d square is equal to only the formula x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. For that purpose, I have written square. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in this session, we will be solving few problems related to distance formula and section formula. So we have learnt the coordinate planes in three-dimensional. That is, we have learnt representing any point or any plane in a three-dimensional way. So now we have also learnt how to derive and how to find the distance of a point from the origin or distance of any 2 points. Similarly, we have learnt the section formula, that is when a line segment is divided by any point in the ratio m:n. We have studied the different cases of external, midpoint as well as when it is divided in the ratio k:1. Let's work out the problems related to it. So distance formula is given by, we can write it as small d is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Because all the points in the three-dimensional axis is represented using the triplets x, y, z. So we have three particular components here. Next, the section formula for any point p of x comma y is given by mx2 plus nx1 divided by m plus n. Similarly, my2 plus my1 divided by m plus n and mz2 plus nz1 divided by m plus n. A basic section formula when you are going to find the coordinates of a point which divides the line in the ratio m:n internally. Now let's look at the problems now. Find the distance between the following pairs of points. So we have a points 1, -3, 4, 4, -4, 1 and 2. Let's take this as x1, y1, z1, x2, y2, z2. Look at the coordinates now. So we have x1 is equal to 1, y1 is equal to -3, z1 is equal to 4. Similarly, x2 is equal to -4, y2 is equal to 1, z2 is equal to 2. Now apply the distance formula, small d. You can take it as square root of, write the formula, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So this is the formula. Let's apply the formula. It is the square root of, so we have x2 is -4, x1 is -1 whole square. Next we have y2 as 1, y1 as -3, minus of -3 becomes +3. Next we have z2 as 2, z1 as 4, so it is -4 whole square. So here clearly it is -4 minus 1, -5, -5 whole square is 25. Next we have 1 plus 3, 4, 4 square is 16, plus 2 minus 4 is -2, -2 whole square is 4. So square root, so this is 25 plus 20, which is equal to root 45. So this is the distance of these 2 points. We can also reduce root 45 into 9 5s. Since 9 is a square number, you can write it outside the square root. So we can write this as 3 root 5 units. Any units, it may be in centimeter, meter, anything. So 3 root 5 units. Next question, -3, 7, 2, 2, 4, -1. So again, apply the distance formula here also. D is equal to x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square under the square root. Now let's apply this. What is x2? We have 2. x1 is minus 3. Minus of minus 3 is plus 3. Next, y2 is 4. y1 is 7. So minus 7 whole square plus z2 is minus 1. z1 is 2. So which becomes whole square under the square root. Now we have 2 plus 3, 5. So 25 plus 4 minus 7 is minus 3. Minus 3 whole square is 9. Next, minus 1 minus 2 is minus 3. Again, minus 3 whole square is 9. So it is root 43 units. So this is how we can find the distance between any 2 points using the distance formula. Next question. Show that the points minus 2, 3, 5, 1, 2, 3 and 7, 0, minus 1 are collinear. We have to show that these 3 points are collinear. How to show that they are collinear? Suppose we have any 3 points on the same straight line. Let me consider this as A, B, C. Let me apply the distance formula here. So the distance AB can be calculated using the distance formula. Again, the distance BC can be calculated. Again, the distance AC can also be calculated. So what I can see here, AC will be equal to AB plus BC. So the distance of AC is the sum of distance of AB plus BC. If we prove this result using the distance formula, we can say that they are collinear. So let's see now the distance between 2 pairs of points in each time. Now let's take the first 2 points. Let us apply the distance formula. So once write the formula for your purpose. So it is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square under the square root again. So therefore here also what I can take, so let's take the first 2 points now. So distance is equal to, I can take this as x1 y1 z1, this as x2 y2 z2. So this becomes 1 plus 2 whole square, next 2 minus 3 whole square, next 3 minus 5 whole square under the square root. So let me mark this point as A, B and C. So here I am going to find the distance of AB. So therefore AB is equal to 3 square, so 9. So this is minus 1 square plus 1, minus 2 whole square plus 4. So it is root 14. Now let's take for B and C now. So let us apply the distance formula for BC. Again, don't need to substitute the formula again. So just write the values. Take this as x1, y1, z1 and this as x2, y2, z2. So this becomes 7 minus 1 whole square plus 0 minus 2 whole square plus minus 1 minus 3 whole square. Now calculate. BC is equal to 6 square 36 plus 4. 4 square is 16. So this is equal to root 56. So which I can write as 4 into 14. So 4 into 14 I can write this as. So which is equal to 2 root 14. Now let's take the points A and C. So let us see the value for AC. AC is equal to now 7 plus 2 whole square and 0 minus 3 whole square and minus 1 minus 5 whole square under the square root. So therefore AC is equal to now 7 plus 2 is 9. 9 square is 81. 3 square is 9 and 6 square is 36. So here you will get this as 81 plus 9 90. 90 plus 36 126. So this can be written as 9 into 14. So which is equal to 3 root 14. Now clearly you can observe this condition is satisfying. So look at here, add AB plus BC. AB plus BC is root 14 plus 2 root 14. Root 14 plus 2 root 14, which is equal to 3 root 14. What is 3 root 14? It is AC. Now we got the condition is satisfying. So therefore what I can write here? So therefore A, B, C are collinear. So we can write this as A, B, C are collinear. Next question. Verify 0, 7, minus 10, 1, 6, minus 6, 4, 9, minus 6 are the vertices of an isosceles triangle. If two sides of a triangle are equal, then we say it is isosceles triangle. Now we have given three vertices. So I can find the distance formula. So if I find the distance formula of all the three, if any two sides of the triangle are equal by the distance formula, we can say they are the vertices of an isosceles triangle. So let us consider the given points as A, B, C. Now write the distance formula. Distance formula D is equal to x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square under the square root. So let's see now AB. Distance AB is 1 minus 0 whole square plus 6 minus 7 whole square plus minus 6 plus 10 whole square under the square root. So we'll get 1 plus 1 plus 16, which is equal to root 18. Minus 6 plus 10 is 4, 4 square is 16, 6 minus 7 is 1, 1 square is 1. Next we have BC. Let's take B and C. It is 4 minus 1 whole square plus 9 minus 6 whole square plus minus 6 plus 6 whole square. Because we have minus 6 here, minus of minus 6 becomes cancels. So now this is 4 minus 1, 3 square 9. 9 minus 6, 3 square 9. So which we got as root 18. So now we can stop here or we can calculate the other side AC also. But to satisfy the given condition, I need any two sides of the triangle must be equal. So we got side AB is equal to BC. When two sides are equal, we can conclude that the given point is an example for isosceles triangle. So therefore, A, B and C are vertices of isosceles triangle. So hence we have proved it. So the next question is, find the coordinates of the point which divides the line segment joining the points minus 2, 3, 5, 1, minus 4, 6 in the ratio 2:3 internally, 2:3 externally. Now this is section formula. We are going to find the coordinates of a point which is dividing the line segment joining the 2 points which is given. So let's take this point as x1, y1, z1 and this point as x2, y2, z2. Ratio is given in the form m:n. So both in the internal and external condition, it is 2:3 only. So what is the coordinate of a point? So when it divides internally, we write P of x, y, z is equal to mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n, mz2 plus nz1 divided by m plus n. So now let's substitute the points here. So we have m as 2, x2 as 1 plus n as 3, x1 as minus 2. and m plus n is 2 plus 3. So let's look at for the next coordinate. M is 2, y2 is minus 4, n is 3, y1 is 3 divided by 2 plus 3. Next, for the z coordinate, so we have mz2 plus nz1 now. So that is 2 into 6 plus 3 into 5 divided by 2 plus 3. Now let's solve this. This is 2 minus 6 divided by 5, comma, so minus 8 plus 9 divided by 5, comma, 12 plus 15 divided by 5. So 2 minus 6 is minus 4. So it is equal to minus 4 by 5, comma, minus 8 plus 9 is 1 by 5. So 12 plus 15 is 27. So it is 27 by 5. So this is the coordinate of a point which divides the line in an internal form. So now let's look at the same condition for an external form. So the points given are minus 2, 3, 5 and 1, minus 4, 6. M is 2, N is 3. Now let us write the section formula of a point when it divides the line externally. So now we have P of x comma y comma z is equal to mx2 minus nx1 divided by m minus n. Next, my2 minus ny1 divided by m minus n. mz2 minus nz1 divided by m minus n. So now let's see the result now. So m we have, so m is 2, x2 is 1, minus n is 3, minus 2, whole divided by 2 minus 3. Next we have 2 into minus 4 minus 3 into 3 divided by 2 minus 3. Next we have 2 into 6 minus 3 into 5 divided by 2 minus 3. So we have 2 minus of minus 6, 6 plus 6 divided by minus 1, comma, minus 8, minus 9 divided by minus 1. Next we have 12 minus 15 divided by minus 1. So 2 plus 6 is 8 and it becomes minus 8. Here minus 8 minus 9 is minus 17. So minus 17 by minus 1 becomes 17. Next we have 12 minus 15 minus 3. Minus 3 by minus 1 is 3. So this is the same point if it's divide the line in external form. Next, question number 5. We have find the equation of the set of points which are equidistant from the point 1, 2, 3, 3, 2, minus 1. We have a point P which is equidistant from the point A and B. So equidistance means it can be a midpoint or it may be any point which is at equal distance of AB. So what I can write here? I can write here AP is equal to PB. Here I can apply two methods to find the coordinates of P. Let's see the first method. So here I can use the distance formula. They have given their equidistant. Equidistance means I can write AP is equal to BP. So let's see now. AP is equal to BP. Now let me take this as the coordinate x, y, z. So if AP is equal to BP, what I can write here? AP square is equal to BP square. Since the distance formula is with the square root, if we square on both sides, we get d square is equal to only the formula x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. For that purpose, I have written square here. So if you can't write square, write the formula, then square it. So without square also, we can apply the distance formula. Let's apply the distance formula with A and P now. So what I'll get here is x minus 1 whole square plus y minus 2 whole square plus z minus 3 whole square under the square root. Similarly, here I'll get x minus 3 whole square plus y minus 2 whole square plus z plus 1 whole square under the square root. So what I can write here, squaring on both sides, we can remove the square root. I am left with x minus 1 whole square plus y minus 2 whole square plus z minus 3 whole square. Here I will get x minus 3 whole square plus y minus 2 whole square plus z plus 1 whole square. I can cancel y minus 2 whole square, y minus 2 whole square on both sides. Let expand the remaining term. This is x square plus 1 minus 2x. This is z square plus 9 minus 6z. Here x square plus 9 minus 6x plus z square plus 1 plus 2z. Now I can cancel plus 9 on both sides, x square on both sides, z square on both sides. So also I can cancel plus 1 on both sides. So shift the remaining equation to the left hand side of the equation. So here I have minus 2x minus 6z, and when you shift 6x it becomes plus 6x, and when you shift 2z it becomes minus 2z is equal to 0. So here you can write 4x minus 8z is equal to 0, or when you divide it by 4 you will get x minus 2z is equal to 0. So this is the equation of the set of points which we can use the distance formula. So the other alternative method is that you can also find the coordinates of point P using midpoint formula and substitute in the general form of an equation. You will get the same result, that is x minus 2z is equal to 0. The next question, 6th, are the points A 369, B 10, 20, 30, C 25 minus 41, 5 vertices of a right angled triangle. So what do you mean by a right angled triangle? One angled at 90 degrees. Suppose we have any right angle triangle like this. So let me take P, Q and R. Then Pythagoras theorem satisfies PR square is equal to PQ square plus QR square. So by finding the distance formula separately and verifying whether the square of the hypotenuse is equal to sum of the squares of the other two sides, we can say whether the given vertices or the vertices of right angle triangle. Let's see now. So first, let me find the distance AB. So here, let me consider AB is a right angle triangle. I don't know at which vertices it is right angle, whether at B or C. So let's verify the result. Let's check AB square now, or AB. So AB is square root of the formula. So if you square it, no need to write the square root. Just write the formula x2 minus x1 whole square. So write it as 10 minus 3 whole square. Next we have 20 minus 6 whole square plus 30 minus 9 whole square. So which is 10 minus 3 is 7, 7 square is 49, 20 minus 6 is 14, 14 square is 196, 30 minus 9 is 21, 21 square is 441. So when you add all this, you will get AB square as 686. Now let's see the result for BC. So BC square I'll take. BC square is 25 minus 10 whole square minus 41 minus 20 whole square plus 5 minus 30 whole square. So which is 15 square to 25 plus, so we will get 61 square which is 3721 and 25 square which is 625. So when you add this, you will get BC square is equal to 4571. So let's find for AC now. So AC square is equal to 25 minus 3 whole square plus minus 41 minus 6 whole square plus 5 minus 9 whole square. So let's add this. So 25 minus 3 is 22, 22 square is 484. Minus 41 minus 6 is minus 47. 47 square is 2209. Plus 5 minus 9 is 4. 4 square is 16. So when you add, you will get AC square is equal to 2709. Now clearly, just verify here, when you add any two sides, will you get the third side? So the maximum value is BC square. So let's add AB square plus AC square now here. So if I add AB square plus AC square, so AB square plus AC square, let's add it now. So AB square is 686 and AC square is 2709, whose value is 3395, and this is not equal to 4571. So therefore, AB square plus AC square is not equal to BC square. So therefore, A, B and C are not vertices of right angle triangle. So hence we have proved. So in this similar way, any 3 points can be given to verify whether they are the sides of a square, they are the sides of a rectangle, or they are the sides of a parallelogram, sides of an equilateral triangle. So by looking at the conditions, for example, for an equilateral triangle, all sides must be equal. So therefore, all the AB, BC, CA component must be equal. If you have given 4 vertices, then you can find the conditions for a quadrilateral. To be a square, all sides must be equal. To be a rhombus also, all sides must be equal. To be a parallelogram or a rectangle, opposite sides must be equal. So if any two sides and the other two sides, by using the distance formula, are equal, we can verify all the conditions which satisfies the required result. So in this way, we have also proved the given points or the vertices cannot form a right angle triangle. So therefore, this is where the applications of distance formula are used. We will meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.